All right, here's another video. An email came in asking, how does cosine equal to both sine of pi minus x and also pi over 2 minus x and sine of pi over 2 plus x? The short story of it is cast rule, right? If I have, for example, cosine of pi over 4, that's 45 degrees right here. That can also be equal to 3 pi over 4, right? But negative. Can also equal to, what is this? Negative cos of 5 pi over 4. It could also equal to positive, in the fourth quadrant, cos of 7 pi over 4. Right? If cosine of pi over 4 can be rewritten in 3 other variations of it because of cast rule, well, you can imagine how cosine of x could be equal to 2 different relationships of sine. But let me try to explain using coordinates. If I have cosine of pi over 6, then the correlated angle would be 5 pi over 6. No, excuse me, 2 pi over 6, right? Or just pi over 3, because if I add these two fractions together, I get myself pi over 2, which you know is 90 degrees. So if I have cosine of pi over 6, it is equal to the sine of pi over 3. Again, if you want me to prove that, I can. Pi over 6. Cosine of pi over 6, well, cosine of anything is adjacent over hypotenuse. In other words, x value over I value, r value. If I were to draw the related triangle, or the correlated angle of this would be pi over 3. And if I did sine of pi over 3, well, based on this angle, what's my opposite side of the triangle? It would be the x value here. And what's my hypotenuse? It would still be r. So pi over 6 of cos sine pi over 3 gives me the same value. Henceforth, that's that. And I have proven, in that sense, using a simple case, that this makes sense. So this is pi over 2 minus pi over 6. Or if I want to follow suit, you can also say cosine of pi over 6 is equal to pi over 2 minus pi over 3. And therefore, this is sine of pi over 3. Okay, let us approach the other one. If I am talking about an angle, for example, let's pretend this angle is, so that's pi over 2 plus something. No, let's keep it similar. Let's pretend this is pi over 6. All right, so if this is in fact 6, so this sine pi over 2 plus pi over 6 would be 4 pi over 6, which again, I'll write it here. Pi over 2 plus pi over 6. Now, how does it convert when you use cofunctions? Well, the cofunction, again, let's put it this way. By cast rule, if this is pi over 6, this angle becomes pi over 3. As you know, pi over 3 plus pi over 6 is equal to pi over 2, right? I'm using cast rule, C-A-S-T, sine of 4 pi over 6, right? This angle right here, 4 pi over 6, is going to be equal to pi over 3. So let's assume this triangle is pi over 3. All right, well, if this is sine pi over 3, what's the correlated angle of pi over 3? It is pi over 6. We already know this. So sine of pi over 3 can be rewritten as cosine of pi over 6. But wait, sine of pi over 3 was originally sine pi over 2 plus pi over 6. And there we have proven, just simply from Castro, that this co-identity is true. That's a bit of a roundabout way to explain what you're asking. I hope I addressed the question, but short story is sine, cosine, tangent, all of these relationships, there are, because we're talking about a circle here, and since it all refers to x, y, and r values, and it's simply a difference of x values being negative and y values being negative, etc., and the r value never being negative, sine, cosine, and tangent can have equivalent ratios or equivalent expressions that equal the same value. Okay? If there is a specific question that you wanted to address, or if there was a textbook question that might help apply this information, please send a question my way. Otherwise, hope this helps, and I'll see you in the next one.